Bismillahirrahmanirrahim. Hello everybody, hope you are doing well. This is the time of exams, official exams. I hope you all the best. This is an exercise which is actually a theorem. It says that if we have a function f from R into R which is continuous and it is also periodic. If it is continuous and periodic, this function is actually uniformly continuous. How we can prove this? It is actually very easy. Since f is periodic and continuous, then a period t, which is the smallest which is called the primitive, exists. Primitive t exists. Anyway, a period exists since it is periodic. Let us consider f from minus p to p closed in R. This function reduced to this closed interval, sub-closed interval from R, is continuous. Since it is continuous on closed and bounded interval, using the Hein theorem, it is proved in the previous video. This gives us the right to say that f is uniformly continuous on minus p to p. If it is uniformly continuous on minus p to p, this is equivalent to say that for all epsilon greater than 0, there exists delta which depends on epsilon greater than 0, such that for all x and y, for all x prime and y prime from the closed interval minus p to p, that satisfy x prime minus y prime less than or equal delta, this delta, which depends on epsilon delta. This implies that f of x prime minus f of y prime is less than or equal to epsilon. This is the first step, the preparation. This is the first step. So keep this in our minds and let us move to prove that f is actually uniformly continuous on or R. Let x and y be any given numbers from R and not from minus p to p, such that what? X minus y are less or equal to what? Are less or equal to this delta. This exists because f is uniformly continuous on the closed and bounded interval. So this delta, then let us consider f of x minus f of y. If we win to prove that this is less than or equal epsilon for any given epsilon, in this case we can say that f is actually uniformly continuous. To this end, what we can say, since f is periodic, so there exists k from z such that x plus k, the period p, belongs to 0p. Why? Because f is a periodic function, and since it is periodic, so the same value are repeated periodically, so this is true. If this is true, we will take the same k and we will consider y plus the same k p this element actually belongs to this interval. This belongs to if we take strictly less, but actually this belongs to minus p to p. Why this is true? This is true because the following. We have considered that x minus y is less than delta. This delta is this one. So this is given. This is we are sure that this exists because it is uniformly continuous. If this is true, so y from this relation, y is less than or equal to x plus delta and greater than or equal to x minus delta. But this, if we add to both sides of this double inequalities, if we add kp the same, this will be x plus kp minus delta less than or equal to y plus kp less than or equal to x plus kp plus delta. But x plus kp belongs to 0p. This means that the smallest possible value here is 1x plus kp equal to 0. So this element x plus kp belongs to minus delta, and this is p, so p plus delta. But since our function is a periodic function, without loss of generality, we can take delta, we can always take delta less than or equal to p or strictly less than p. In this case, this will be included in minus p to p. So once again, sorry here, I mean y plus kp. I mean y plus kp. So what we have? We have from side, we have x plus kp belongs to 0p. And y plus kp belongs to minus p to p. These two elements, if we denote them by x prime and y prime, we will be in our rights. Why? Because x prime and y prime belongs to minus p to p. This means that x prime minus y prime less than delta. This implies that this is true. Let us finish this work. So remember, this is very important, we keep the same delta that is ensured by the fact that f is uniformly continuous on the closed interval minus p to p. At the last, f of x minus f of y, because our function is periodic, this is equal to f of x plus kp minus f of y plus kp. And because this is x prime and this is y prime and they belongs to minus p to p, those are less than or epsilon since x prime minus y prime is less than or equal delta. As a conclusion, for all epsilon greater than 0, there exists delta. This delta is the green one. I mean that this delta is from the fact that f is uniformly continuous on minus p to p closed and bounded interval, such that for all x and y from R which verify x minus y less than delta, this implies that f of x minus f of y, this is equal actually to this one, but these are less than epsilon since x prime and y prime belongs to minus p to p. This finishes this video. Thank you very much. Just before finishing this video, using this theorem, you can prove, for example, that cosine plus sine, cosine 3x plus sine 7x, all this you can say that they are uniformly continuous. Why? Because they are continuous and periodic, and you can generalize this formula to say that every continuous and periodic function is actually uniformly continuous. I will give you inshallah a short summary about situation that you can say that your function is actually uniformly continuous without proving using the characterization. Thank you very much. Next time, inshallah.